Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 12 or 2nd PUC Physics Chapter 1, that is Electric Charges and Fields, Class 2. From basic to advanced level. So watch till end, don't forget to subscribe the channel. If you want PDF copy, just comment PDF. In previous class, we studied electric charges, types of charges, construction of gold leaf electroscope, conductor and insulators. Basic properties of electric charge, that is, additivity of charges, conservation of charges, and quantization of charges. That video link is given in description, don't miss it. Today, starts with Coulomb's law in electrostatics. Let's start. Coulomb's law. State and explain Coulomb's law in electrostatics. Statement. It states that the force between two-point charges is directly proportional to the product of magnitudes of two charges and inversely proportional to square of the distance between them. The force is acting along the line joining two charges. F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. Explanation. Let Q1 Q2 is two-point charges. R is equal to distance between them. F is equal to force between Q1 and Q2. Therefore, F is directly proportional to Q1 Q2. Mark it as equation 1. Then, F is inversely proportional to R square. Mark it as equation 2. From equation 1 and 2, F is proportional to Q1 Q2 by R square. After removing the proportionality, we get F is equal to K into Q1 Q2 by R square. Equation 3, where K is equal to proportionality constant. That is K is equal to 1 by 4 pi epsilon naught. On substituting K in equation 3, we get F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the expression for electrostatic force or Coulomb's law. Note 1. Epsilon naught is called permittivity of free space. SI unit is Coulomb square per Newton per square meter. The value of epsilon naught is equal to 8.854 into 10 to the power minus 12 Coulomb square per Newton per square meter. 2. To find the value of K, that is 1 by 4 pi epsilon naught, substitute values, that is 1 by 4 into 3.14 into 8.854 into 10 to the power minus 12 Coulomb square per Newton per square meter. We get 0.00899 into 10 to the power plus 12. On moving point for 3-digit, we get 8.99 into 10 to the power 9. That is on rounding we get 9 into 10 to the power 9 Newton meter square per square Coulomb. 1 Coulomb. Definition. 1 Coulomb is the charge that when placed at a distance of 1 meter from another identical charge kept in vacuum experiences a force of repulsion of 9 into 10 to the power 9 Newton. Or 1 Coulomb is the charge which repels another identical charge with a force of 9 into 10 to the power 9 Newton when placed at a distance of 1 meter in free space. SI unit of charge is Coulomb, C. Next, define 1 Coulomb using Coulomb's law. According to Coulomb's law, F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. If Q1 is equal to Q2 is equal to 1 Coulomb and R is equal to 1 meter. Substitute in above equation, we get F is equal to 1 by 4 pi epsilon naught into 1 by 1 square. On substituting values of 1 by 4 pi epsilon naught, the final answer is 9 into 10 to the power 9 Newton, meter square, per square coulomb. Define one coulomb of charge in terms of current. One coulomb is that charge flowing through a wire in 1 second if the current is 1 ampere. Next, Coulomb's law in vector form in terms of position vectors of two charges. Or, show that the Coulomb's law agrees with the Newton's third law of motion by taking the position vectors of two charges. Consider 2-point charges Q1 and Q2, located at 2 points in vacuum. Let vector R1 and R2 be position vectors of Q1 and Q2 respectively with reference to O. From triangle law of vector addition, vector R21 is equal to vector R2 minus vector R1, and vector R12 is equal to vector R1 minus vector R2. From Coulomb's law, force exerted on Q2 by Q1 is vector F21 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R21 square into R21 cap. Force exerted on Q1 by Q2 is vector F12 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 square into R12 cap. But R12 is equal to minus R21. Therefore, vector F12 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R21 square into minus R21 cap. From equations 1 and 2, we get vector F21 is equal to minus vector F12. The force exerted by two charges on each other are equal and opposite. Coulomb's law agrees with Newton's third law. Importance of Coulomb's law. 1. The forces exerted by two charges on each other are equal and opposite. Therefore, Coulomb's law agrees Newton's third law. 2. The force act along the line joining the two charges and hence these are central force. Limitations of Coulomb's law. 1. Coulomb's law is applicable only for point charges. 2. It is applicable when the distance between the point charges is greater than 10 to the power minus 15 meter. Note: important for CET, NET. Permittivity of a medium. Permittivity is the ability of the medium to allow the electric field lines to pass through it. Permittivity is defined only for dielectrics, that is insulators. Relative permittivity, or dielectric constant, denoted by epsilon r. Consider two charges Q1 and Q2 are placed in free space, that is air or vacuum, and separated by a distance of r. From Coulomb's law, F air is equal to 1 by 4 pi epsilon naught into Q1 Q2 by r square. Equation 1. When Q1 and Q2 are placed in dielectric medium, F medium is equal to 1 by 4 pi epsilon into Q1 Q2 by r square. Equation 2. From equation 1 and 2, Fa by Fm is equal to epsilon by epsilon naught is equal to epsilon r. Dielectric constant, or relative permittivity, is unitless, that is no unit, and dimensionless, that is no dimension. Value of dielectric constant depends on the temperature. It is also called as specific inductive capacity of the medium. Difference between charge and mass. Charge and mass. 1. The charge may be positive or negative. The mass is always positive. 2. Charge is conserved. Mass is not conserved, because mass can be converted into energy and vice versa. 3. Charge is quantized. Mass is not considered to be quantized. 4. Charge does not exist without mass. Mass can exist without net charge. 5. Charge does not vary with velocity. Mass increases with increasing velocity. 6. Charge is derived physical quantity. Mass is fundamental physical quantity. 7. SI unit of charge is Coulomb. SI unit of mass is kg. Now let's look some other properties of electric charges. 1. The electric charge is conserved. 2. The electric charge is quantized. 3. The charge is additive. 4. Like charges repel each other and unlike charges attract each other. 5. A charged body attracts light uncharged bodies. 6. Charge always reside on the outer surface of the conductor. 7. Charge always accumulate at the sharp edges on the conductor. 8. Magnitude of charges does not depend on its motion. 9. Charges produce magnetic field when they are in motion. 10. Charge is a scalar quantity. 11. Charge is scalar, its SI unit is Coulomb. Principle of superposition of electrostatic forces. It states that force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to other charges taken one at a time. The individual forces are unaffected due to the presence of other charges. Application of principle of superposition to find the force between system of charges. Consider a system of n stationary charges. Let force on Q1 by Q2 is vector F12 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R12 square into R12 cap. Force on Q1 by Q3 is vector F13 is equal to 1 by 4 pi epsilon naught into Q1 Q3 by R13 square into R13 cap. Similarly, force on Q1 by Qn is force on Q1 by Qn is vector F1n is equal to 1 by 4 pi epsilon naught into Q1 Qn by R1n square into R1n cap. According to principle of superposition, net force on Q1 is vector F1 is equal to F12 plus F13 plus F14 plus up to plus F1n. On substituting the values, and take Q1 by 4 pi epsilon naught, common, finally we get vector F1 is equal to Q1 by 4 pi epsilon naught into summation I is equal to 2 to n, Qi by R1I square into R1I cap. This completes Coulomb's law. In next class starts with electric fields. Share with your friends and don't forget to subscribe the channel for more updates.